Hello everyone, welcome to a new video. Today we will look into chi-square testing. Chi-square testing, as we all know, is a type of hypothesis testing which is non-parametric in nature. So what chi-square test does is basically gives us an idea if two categorical variables are related to each other or not. In this example, if we see, there is a data set which contains three geographies and three diseases. So we try to understand if the diseases or the occurrence of diseases is it influenced by the geographies or not. So our null hypothesis would be that there is no relationship, and the alternate hypothesis would be that there is a relationship. So over here, by relationship I mean that the diseases are not influenced or affected by the geographies. Okay, has no relationship with the geographies. Now for any hypothesis test we would need a level of significance, that is alpha. Now generally alpha is taken to be as 0.05. It can be of any other value as well depending on experimental or historical understanding. But generally we take it as 0.05. Okay. So we have the null hypothesis, the alternate hypothesis, and the level of significance. Now null hypothesis, coming back to it, should always be the status quo. In this case, that would be no relationship. The alternate hypothesis would be the opposite of that. Now, for chi-square testing, we need a thing called a degree of freedom. It would be D. D would be number of rows minus 1 into number of columns minus 1. There are 3 rows and 3 columns. So basically, degree of freedom would be 3 minus 1 into 3 minus 1. That would be basically 4. Okay. So basically, the degree of freedom is 4. Now, what is chi-square testing, or what is the working formula of it? Chi-square is basically observed minus expected whole square by expected. E stands for expected and O stands for observed. Okay. So what would be the observed values? So observed values would be nothing but these values. That is typhoid for India, the observed value is 31. So there are 31 observed cases amongst the entire sample that we have surveyed. The 31 cases out of those were typhoid that were from India. For cholera, 2 were from India. For diarrhea, 53 were from India. So these are the observed values. But what would be the expected values? Now the expected values we have to calculate. For example, for typhoid, if I want to find E, so we over here, we have calculated the expected values. Let us see how we are getting it. For example, I want to find the expected value of typhoid for India. It would be basically the total number of typhoid cases, that is 90. Total number of cases in India, that is 86, by total number of the sample, basically the sample size, that is 250. If we calculate this, this comes out to be basically 30.9, or to be precise 30.96. Okay, this is how we find E. We see the observed value is 31, the expected value is 30.96. 31 is for typhoid in India. Similarly, for Ecuador, typhoid the expected value of typhoid for Ecuador observed is 14, expected to be 23.04. How would we find that? Similarly, 90 into 64 divided by 250. That would give us 23.04. Okay. So now we have the E. So the next step is to find the observed point is expected, then square that and then divide it by the expected. So once we do that, we have the chi-square value for each and every geography and each and every disease. Now what we have to do is sum up the chi-square values and get the total. That is the chi-square value for the entire test. So for the chi-square value for the entire test, for the entire sample, I would say, chi-square calculated is basically the summation of this, that is comes out to be 125.51. That is summing up 0.001 0.00015 plus 3.546 plus 2.25 plus 16.83 till 36.10. It gives us 125.51. This is our chi-square calculated. Now to find out what is the value or what is the what our takeaway from the test is, that is to tell us whether our null hypothesis is correct or the alternate hypothesis is correct, we have to compare this value to something. How do we do that? We have the calculated value, we have our level of significance, right? Now, and we also have our degree of freedom, that is 4. Now using these three, there's a table called a chi-square table, which looks something like this. So degree of freedom was 4. We have our level of significance as 0.05. Now if we see the value, chi-square value, tabular chi-square value for level of significance 0.05 and degree of freedom 4 is 9.488. So basically chi-square tabular .48. Just let me recheck once. Yes, it's 9.488. Okay. Now if our chi-square calculated is greater than chi-square tabular, then in that case we have to reject, we have to accept our null hypothesis. Okay. Chi-square value is greater than, calculated value is greater than the tabular value, that is the critical value. So the tabular chi-square value is also known as critical value. Now if our calculated value is greater than the critical value, in that case we accept the null hypothesis. That is, we do not have enough evidence to reject it. Okay. In this case it is so, our calculated value is way bigger than the tabular value, hence we accept the null hypothesis and reject the null alternate hypothesis. So we say that there is no relationship between the diseases and the geographies because our calculated value is greater than the tabular value. The chi-square tabular value is lesser than the chi-square calculated value. Hence, we do not have enough evidence to reject the null hypothesis. Hence, we are accepting the null hypothesis and in turn rejecting the alternate hypothesis. So this is all for today. In the next video, we'll go into the Python implementation of chi-square tests. I hope you liked it. And if you did, do not forget to like, share and subscribe. Bye.